was ready. Perfect. All right. So yesterday we talked about multiplied rational numbers. Today we're talking about divide rational numbers or dividing rational numbers. And there's really one note that I need to put with words. Use the same rules for multiplying. So we talked about the rules for multiplying yesterday. We're going to use the same rules for dividing today, which is really nice. We were dealing with multiplying or dividing rational numbers. Okay, once you get that written down, I'm going to give you guys a little verbal quiz again. And you need to listen to my words because I will change key parts of my phrases or my questions to give you a different answer. Okay. What's a positive times a positive? Mary? Positive. What's a negative times a negative? Alex? Positive. What's a negative times a positive? Matthew? Negative. What's a negative plus a negative? Jackson?
Negative plus a negative is a negative.
Negative. Now, what was that key word I used? Plus or add. Okay. What's a negative times a positive, Hudson? Negative. What's a positive times a positive? Michelle?
Positive.
What's a positive plus a positive? Josiah? What's a positive plus a negative? Hagen?
Negative.
Positive plus a negative?
It can be both. It just depends which one has the bigger absolute value.
Wow, that's what I want. Whichever one has a greater absolute value, that's the sign that we get. And so it depends. Okay, are there differences among the rules of adding and subtracting and multiplying, dividing? Yes, you need to keep those straight. But thankfully, dividing is the same as multiplying. Okay, so here's what I put on my notes. What's a positive divided by a positive going to get me? Everyone?
Positive.
Oh, 3 of you? Okay. What's a positive divided by a positive going to get me? Everybody? Positive. What's a negative divided by a negative going to get me?
Positive.
Also a positive, which is the same as multiplying, right? Two numbers with the same sign that are multiplied get me positive results. Same with division. Okay. What's a positive divided by a negative going to get me?
Negative.
Negative. What's a negative divided by a positive going to get me?
Negative.
Negative. So you guys get the rules there? Same exact as multiplying, and we're thankful for that. So if you were listening and if you can read what's on the board, what's a negative divided by a negative? Lana. Negative divided by a negative. Positive. Darius, what's a positive divided by a negative?
Positive divided by negative is negative.
Negative. Jack, a negative divided by a negative.
Positive.
Andrew, a positive times a negative.
Negative.
Sam, a negative divided by a negative.
Negative divided by negative is a positive.
Positive. Brad, a negative plus a negative.
A negative.
Negative. Okay, so good. What I like is when I say the problem, at least some of you are looking up at me, and so you have some idea. And some of you are in your own world right now. When I call on you, you get back to the real world, and you can at least get it after that. Anyone not in the real world right now? Okay. If you answer me, you were in the real world, and I thank you for that. Okay, let's actually look at some examples of what we're going to do. So the first problem I want you to do is I want you to divide 2 1/2 by 5/6. Okay, we have two numbers with the same sign. What's my answer going to be? I have two positives being divided. My answer is going to be automatically positive. So that's nice. And by the way, you guys remember positives together usually give me a positive answer for most operations, except subtraction. Okay, I don't want to deal with it this way. Do you guys remember what I change mixed numbers into?
Well, you make it a fraction.
So I'll have 5 halves divided by 5/6. Okay, but there's another concept that we've looked at maybe in the past to make this not a division problem, but a multiplication problem. Is that even possible? Darius?
Stay, change, flip.
Stay, change, flip is correct. Stay, change, flip. So it's very similar to stay, change, opposite, but is it the same? No, because flipping and opposites are not the same. And I'll give you that in just a moment. Okay, who can give it to me in stay, change, flip real quick? Just read it to me, stay, change, flip. Philip?
2 over 5 divided...
Stay.
Oh, yeah, sorry. 5 over 2 divided by 6 over 5.
Okay, 5 over 2 times 6 over 5. That's all right. Do we get, that's how you write it as a multiplication problem? Okay, this fraction and the original fraction are obviously not the same. 5/6 are not the same thing as 6/5. They are called what of each other? Keyword. Yes, a keyword is, and we're going to get back to the problem in just a bit, reciprocal. Reciprocal is a keyword in pre-algebra, algebra, algebra 1, 2, geometry, pre-calc, calc. So we might use it later. Reciprocal, right? What's another word, though, for reciprocal? It's a technical word in math. It might be in your book. It is in your book. It's there in your book. And it might be highlighted. It might be italicized. Yes, sir? Okay, that we're getting to that later, Hudson. Don't rush us there, Hudson, because we need some time on that. Anybody? Multiplicative inverse. Multiplicative inverse is that other way of saying reciprocal. Write that down, and I'll tell you what I mean by these words and why you need to know them. Okay, it was interesting. The last class, they didn't guess multiplicative inverse. I wrote it down. As I'm writing it down, they're trying to say it. So like multiply, multiplication, multiply. And then I wrote it all out there. Multiplicative. Okay, can you guys say this word right here? Multiplicative inverse. Everybody. Multiplicative inverse. Okay, multiplicative inverse and reciprocal and the informal way of calling it a flip, they're all the same thing. So what's the multiplicative inverse of 1/2? What's the multiplicative inverse of 1/2? Alex?
2 or 2 over 1.
Yep, 2 over 1 or 2. Good. What's the reciprocal of 1/2? 2 over 1 or 2. What is 1/2 flipped? 2 over 1 or 2. So you guys you could use either one of these terms for the flipping of that fraction. You guys okay with that? Because I'm going to ask you many times, hey, what's the multiplicative inverse of 5/6? Somebody? 6/5. And we got that right here. Okay, now it's time to multiply. Wait, we did this yesterday, didn't we? Multiply? So is this new stuff? No, from here on down, it should be familiar, I hope. All right, but what can we do to make our lives easier, Sam?
5 turns into 1, and then 6 and 2 turns into 1, 6 turns into 3.
Good. 1 times 3? 1 times 1? Which is just really 3. Make it as simple as possible. 3. 3 is your answer. Now, how many of you understand your answer? Really? What does your answer mean?
3.
Okay, let me give you some context. Do you guys remember division problems, like word problems when you were probably younger? Here's an example. There are 30 children in a class. You want to divide them into 2 equal groups. How many would be in each group? What's my answer?
15.
Okay, so that's the problem. 30 divided by 2 equals 15, right? You guys get that? How in the world does that work with this problem? It's a division problem and you get 3. Yep, Andrew?
Because 2.5 is 5/6 of 3.
Close. When you use that word of, we're thinking of multiplication. So it's not of, but there is an of, it's a somewhere else. Ready, guys? 30 divided by 2 equals what? 15. What's 15 times 2?
30.
What's 3 times 5/6? there are 3 groups of 5/6 in 2.5. That means there are 3 groups of almost a whole in 2.5. That's what you're saying with your answer. Some of you are like, what? And some of you are like, I hope he doesn't call me to explain. Whatever the response is, that's what you actually mean. And the reason I'm going over that is because you guys, I think almost all of you, can get me this 3. But how many of us can tell me what that means? That's the important question. Okay, we'll keep drilling you on that in just a bit. Okay, another problem that is not the same, but similar, is going to be this one. Ooh. Not only do you get fractions, you also will get today, yeah, decimals. Yay. Did someone say yay? Good, bonus points. Yeah, then I love these. Okay. I have negative 168 10,000ths divided by negative 5 6/10. Okay. The thing that's really throwing me off right now are those negative signs. I'm going to deal with them right now. A negative divided by a negative is a positive. So I'm already done with the signs. It's a positive number. So I don't even think about those signs anymore. And this is really cool. I want to see if you're paying attention. When you're dividing 2 numbers, like you are up here, the top number or the first number always goes in the box. Always goes in the box. So what should go in the box? I think I heard it. I heard a lot of different things. All right, that's the number that goes in the box. Therefore, what should go outside the box? 5.6. Good. What about the signs, Mr. Ray? What about those negatives? Did we deal with the negatives already? Yes. So you're done with them. Don't worry about them. You already know it's a positive answer. Okay, but can I divide just the way it is? No. What do I have to change? Hudson? Which one? Okay, I need to make sure this is a whole number. This needs to be a whole number. If this is a whole number, great. If it's a decimal, fine. But this has to be a whole number. How do I do that? Philip?
So you take the decimal and move it 1 time to the right.
Okay.
And then you do the same thing with the other decimal.
Okay, so it goes right there. I'll put a little arrowhead. And I rewrite it for myself because sometimes I get confused with where is it? Where did I move it? Here. That's just me. I'm going to put it like this. And notice I didn't put 0.168. I just put 0.168. Or you could just do 0.168. Bring that decimal up. Now you can work it out. 56 goes into 0. 0 times 56 goes into 1. 56 goes into 16. 56 goes into 168. Exactly 3 times. And you're like, wait, how's that? Well, I don't know. Maybe this. And if you didn't know that off the top of your head, it's okay, guess. And as you keep guessing, guys, you get better at your guessing. So if you don't want to guess, you're like, I just want someone to tell me the answer. You might get the answer that time, but when it comes to another problem where no one can help you, I don't even know what to do. So just guess. Sometimes you'll be really off. You did 56 times 7. Oh, that's a huge number. That was way too high. Then you'll learn and you'll get better. What's my answer? No, I want the answer properly. And someone said positive, someone said the number, but I want the answer the way it's supposed to be read.
3,000?
Yeah, positive 3,000ths. And you don't have to put that plus sign. I do it for emphasis, which is actually interesting. Remember I told you how to read a division problem? How many groups, 3,000ths, of this number fits in the top number? So can you fit very many of these in here? No, you can only fit 3,000ths of that piece. Does that kind of make sense to somebody? Okay, that's number sense. All right, it's funny. I gave the other class the same problem. I'm not doing this to you guys. I'm being a little nicer today. I gave them the problem, had them work it out, and some of them gave me answers that are thousands of times bigger than that answer. Do you think that's significant?
Yeah.
Do you think it's a difference between 1 and 1,000? Is there a difference there? Yeah. So they're giving me numbers that are thousands of times bigger. Do you think I'm going to count that as correct? No. You got to make sure that 3 is in the right place value and your decimal is where it belongs. Sam?
How did... I don't understand. So 56 goes into 68 one time.
50, so technically, 5.6, I'm going to use the informal way, 5.6 fits into 0.0168, only 3/100ths. You can fit a tiny piece of this in here. And that's how tiny the piece is. It's weird, right? That's okay. You don't have to know that for yourself. I'm just going to keep bringing that up. Okay, how many of you think you could do these on your own? Good, because you're going to do one on your own. And I'm going to check your answer. And I need one person, one and only one for this first example on the board, to do it on the board after you do it on your own. Darius, I think you're my volunteer. 3 divided by negative 75 thousandths. All right, so Darius, you work it out. Everyone else work it out. I'm going to come by and see your answers, see what you're getting. You can give me a number that's close, only off by a few thousand. Or you can give me the actual. So be careful with your decimal point. Be careful with your place value. Be careful with your signs. There's a lot to be careful with. Man, technical. Speaking of technical, if you guys are looking at that whiteboard, 1 year from now, you will see that. And you will do that. And you will like it. Yes. That's an important part. Now, at first, will you understand it? I don't know. At second glance, will you understand it? Maybe. Third glance, I hope. Fourth glance, you better. Fifth glance, no excuses. Sixth glance, okay, I'm done. Yes, sir? Yeah, I'm checking your guys' answers as they come by. So if I say nothing, that's a good sign. If I looked at your paper, I said nothing. If I say check it, that means something's off. Darius, when you're ready, you can go. Yes, sir.
So the 3 or the 1 in the parentheses goes on the bottom?
The first number goes in the box. Mm-hmm. Always. And some of you are still working, so I can't really say something. Let's switch the 3 in the... Switch the numbers. 3 goes in the box. 3 goes in the box. That's okay. It's a common thing I'm pulling out right now. 3 goes in the box.
I'm really confused.
Mm-hmm.
Because I don't know what to do.
Yeah, so you have this number divided by that number, right? Mm-hmm. So you set up your box. What number goes in the box? 3. The first number always goes in the box. And then that other number goes outside. And you don't even have to put the negative. Just put the number. Yeah. 0.075. Okay, but can you divide that just the way it is? Because you have to move the decimal here how many times?
Once.
You want to make this a whole number. So you got to move it how many times?
3 times.
3 times. And if you move it there 3 times, how many times do you move it here? 3 times. So do that, and so you'll add your 3 zeros. So 75 into 3,000. How many of you, you did put 3 outside the box? And I saw some of your papers, so if you say no, that's not true.
I think stage 1.
Oh, so you made it into a whole number, 3 over 1, and then 75 over 1,000.
It's pretty nice.
Thank you. Yep. Oh, I think it's because of the sweater. Sorry, we'll back it up. There you go. I like that back button, the little undo button. It's kind of like when Thanos rewinds time. Isn't that what you do? Bring it back up. You messed up, flip it back. You guys know what I'm talking about? No? Yeah? Okay. Okay. Final answer. Circle it, sorry. There's just so we know. Thank you, sir. Now, How many of you, when you flip these two around, you got like 0.012 or 0.15, something like that? 25.0, 25 thousandths, okay. Is 25 thousandths different, negative 25 thousandths, is that different from negative 40? It's thousands of times smaller, thousands. Or actually bigger technically because it's a negative, but thousands of times of a difference. Is that significant? Yes.
Okay,
Yes, ma'am.
I got -4.
Okay, did you move the decimal place 3 times here?
No, so first I did 30,000 over 1,000. The 30,000 over 1,000 times 1,000 over 75.
So you did you made them fractions.
Yes.
Okay, fractions are okay. You could get to them, but it makes it a little complicated because now you're dealing with big numbers that you're having to cancel out. Or you could just divide this one right here. So I would avoid, if it's a decimal problem, do decimals. If it's a fraction, fractions. If it's neither, then you have a choice. Who got 40? Negative 40? Okay. Last one, I'll get a volunteer here. Make sure we get these types of problems. -12.5 divided by 4.5. All right, William, you can do it when you're ready. All right, I need to see it from all of you guys. I need the correct sign, the correct number, and really what I'm asking, how many groups of 4.5 can fit into -12.5? That's what I'm asking. And so does your answer make sense? I'll find out. This one's a little bit trickier for some of you. I wonder who. When you're ready, William, you can come on up. So I want it written as a multiplication problem after you do improper fractions, all that. So show me steps. Don't just give me an answer.
Okay, so...
Sorry, yeah, I'll pull it up. No, you're good.
Okay, so 12 multiplied by 2 equals 24, so that would be 25 halves. And then this is 4 times 2 equals 8, which is 9 halves. So then you would just say change flip, so it would be 25 over 2 times 2 over 9. And so then you would simplify it. And then you would multiply it, so that would be 25 over 9. And then you would simplify it.
Yeah, or convert it, yeah.
Convert it. So 9 can go into 25 twice, and then there will be 7 remaining. So
Good, and it's negative because the negative divided by positive is negative, -2 and 7/9. So how many groups of 4.5 can fit into -12.5? Almost 3 groups in that. Okay. How many of you got -2 and 7/9? Okay, great. Remember yesterday we did multiplying, and how many of you are good with this part up to this part in the lesson? Good, good. Because this is review, and even if it wasn't, hopefully you get that concept. But yesterday, remember the end we did distributive property? It was a little bit tougher to wrap our minds around. This time it's not distributive property, it's looking at a complex fraction. So here, we're going to finish up today with complex fractions. And when I say complex, I mean complex. So here I'm going to give you an example, and maybe you can tell me why it's complex. -80 over 3 1/3. Okay, why is it complex in your opinion? Because I don't like negatives, 80's too big. What's the reason, Alex?
It's technically a fraction number or next number is a fraction.
Okay, yeah, and I'm gonna say it's a fraction within a fraction, and here's the definition of complex fraction. In one number, you have more than one fraction bar. Is that true right here? Yep, so that's complex. By the way, in Algebra 2, you have about 5 or 6 fraction bars in one big fraction. Very complex, but you're dealing with this one, so don't worry about that yet. Okay, they're going to make it very clear which one's the bigger one. They're going to like darken this and make it longer, and this is a smaller one, so we'll see this clearly. Now, you guys need to know what a fraction is. A fraction is a numerator over a... That one I hope you get. Or you could say it's a part over the... Part over the whole. Part of the whole. And then you should be able to say this, that a fraction is a division problem. Isn't it the numerator divided by the denominator? Yes. That's the key to figuring out how to make this simple. Is that simple, by the way, just looking at it? Is it simple? I don't think it is. Let's try to make it simple by thinking of it as a division problem. This is really negative 80 divided by 3 1/3. So why don't you just write it that way? Is it really that complex? Now, this is a problem we kind of dealt with previously. How do I deal with this? Well, what's a negative divided by a positive? Negative divided by positive? Negative. My answer is going to be negative. So whatever it is, negative something. I'm done with the signs. How do I deal with this fractional problem or mixed number, whole number? Yep.
You convert the 3 1/3 into a decimal.
Okay, you can do 3 1/3. That's going to give you 3 repeating. So that's a little harder to deal with when dividing by 80. So what's another option?
You can put 80 over 1 and 3 times 2 equals 9, 7, 6, 0, 8. Then you switch that to expand.
Yep. So we'll do 80 over 1. Change. Flip.
So basically, whatever you do,
Good. Negative 24. How many of you follow that process? So, is this complex right now? Yes. Can you see it as a division problem? I hope so. If you can see it as a division problem, maybe it's not as bad as we thought. And then we get our answer, negative 24. So how many groups of 3 1/3 can fit into 80? About 24 of them. So if you had, basically how many 3's can fit into 80? About 24 of them. Do you guys see what we're saying with division? I don't want you guys to just give me an answer, say, yep, that's the answer. That has to be it. I divide, say, choose, flip. You got to have some understanding. Yep.
So that's an estimate or that's
That's your, yeah, this is exact, but when I'm using the thought process behind it, I'm saying you can fit about 24 groups of 3 in 80. Mm-hmm. Oh, sorry, yeah, Drew?
Are we no estimates in dividing?
No, I'm not making you do estimates today. Yes, Alex?
I think I know what I did wrong,
Uh-huh.
but I got 3 1/3. I think it's because I put the lowest one first in like the stage flipping.
The lowest one first. Yeah, so you didn't have this right here? Like you didn't have 80 over 1 times
Yeah,
3.
I had
1 and 3 times.
1/3 over 10 over 8.
Oh, okay. Listen up, guys. This is actually a good point because this is common. When you're going to do state change flip, before you even get to that step, make sure both of these are improper fractions because some people flip this around, just the 1/3. So they say this is 3 and 3 over 1. That's not state change flip. It's 10/3 to convert it to 3/10. Okay, last problem, and then I'll give you your homework. Speaking of complex, here you go. 6 1/4 divided by, why did I say divided by? 1 1/6. Is that complex?
No.
Oh, wow. Okay, technically, by definition, is it complex? Yes, but is it really that hard is maybe what you're answering. No, change it. It's 6 1/4 divided by 1 1/6. So write it that way. 6 1/4 divided by 1 1/6. And I need a volunteer to come and work this one out. Sam, you can come on up when you're ready. If you want to work it out there or you just want to do it here, it's fine. Yep. And when you guys are done, when you start working on your homework, I'm going to put it up there. I'm going to pass back those practice quizzes that you took a while back. Sorry, it's been so long. But I'm going to put the grade on it, give it to you. The grade was not recorded on Sycamore, but it's still good. That actual quiz is going to be used for the test. So you better keep that quiz and know what you did right or wrong, because you're going to need that for the test. So, Mr. A, should I throw this away? No, I would not throw it away. Can we throw it away? That's your option. I would not take that option. Okay, Sam, again, when you're ready, come on up. And I'm going to check you guys, see how you're doing with this. Sorry? Okay, so he converted them into improper and wrote it as a division problem. So 25 fourths, 7 6. All right, go ahead. Stage change flip.
And then you can't do these.
Okay. So you get 75 over 14. And can that be simplified? Yes, which might take a little bit of effort to do, but...
Do you want me to?
Yeah.
Okay.
So, you know what I do, Sam? If I don't know off the top of my head, I'm going to guess. How many times do you think 14 fits? Throw out a guess.
3, 4, maybe
Which
4.
Okay, so I'll do 14 times 4. I'll do your work. 56.
Okay, 5.
70.
Okay, well then that means
So it's 5.
5.
5, and how many do you have left over?
5.
5. 14ths. Isn't that nice? So did you have to guess a couple times?
Yes.
That's okay. I guess a lot too. All right, that's your answer. 5 and 5/14. I saw that on a lot of papers, which was good. Did you guys get that? All right, your homework is, yeah, I guess you guys all saw it. 22 to 30. Did I say 38? What did I put on there?
No, you said 34.
Yeah. Okay, homework is going to be 22 to 40. Yeah, I did say 40. All right. And then that's going to be evens, and that's pages. And Sophie, I'll get your stuff in just a moment. 19 and 20. And you can go ahead and get started. Goodbye, Swivel.